Welcome to Math with Miss Garrity. We are going to continue our learning about radical expressions today. In addition to just simplifying radical expressions can also be added, subtracted. You can also multiply and divide with them. And there are some rules to follow, starting with adding and subtracting. If you think about a radical term, the m, the number inside the radical sign, is called the radicand, recall. And then the little number up here is called the index. We can add and subtract radical terms if the radicand and the index are exactly the same. For example, radical 2 plus radical 3. This expression cannot be simplified because the radicands are different. So just like we've done for years now, we look to see if there are like terms, and these are not. If we have radical 2 added to 6 radical 2, these would be considered like terms. And so we're collecting the objects. We have 1 radical 2, and we're adding to that 6 radical 2's. So how many total sets of radical 2's are there? 7. So it's almost as if the number in front of the radical, that's our coefficient, and then the radical would be the like terms. Subtracting is the same idea. If we have 10 radical 5, subtract 3 radical 5, we can go ahead and simplify this expression because the radicands are exactly the same and the index is assumed to be 2. So we would just subtract the coefficients and we would have 7 radical 5. And that's a coincidence. So adding and subtracting radical expressions can be done if you have like terms. Now, multiplying, you don't have to have like terms. But multiplying radical expressions may take 3 steps to complete. This is my way of thinking about it. If you have another way, go for it. But you don't need like terms. Don't have to have like terms to multiply. So we could have example 1. We could have our radical 2 multiplied by radical 3, and we can go ahead and multiply those. Now, this example doesn't have 3 steps. This one would just take 1 step. We multiply the radicands and we're finished. Now, multiplying, you do need to have the same index, but you don't need to have the same radicand. Another example, what if we started with 4 radical 2's, and then we were going to multiply that by a radical 5? Well, this is going to take 2 steps to complete. You're going to first look at the coefficients, multiply the coefficients, then you can multiply the radicands. Example 3. What if we have 7 radical 2 times negative 3 radical 6. Okay, both terms have coefficients, so we're going to follow our multiplying rules with positive and negative numbers, and we're going to take 7 times negative 3, and we're going to get negative 21. Now we look and we see both radicals have the index of 2, and their radicands are different, so we'll go ahead and just multiply their radicands. So the first step was to multiply the coefficients. The second step was to multiply the radicands. Now the third step, and we've been doing this, I've been doing this, whether you knew it or not. Once you find the product of your radical expressions, you should always take this last step and ask yourself if the radicand is simplified. Does the radicand have any perfect square factors? 10 does not, 6 does not, but 12 does have a perfect square factor. So off to the side, I'm going to think to myself, wait a minute, radical 12 is the same thing as radical 4 times radical 3, and that simplifies to 2 times radical 3. So I'm going to take this term, this expression of negative 21, and I'm going to multiply it by the equivalent of radical 12 in simplified form, which is 2 radical 3. Now I've got to go ahead and simplify the coefficients again. Negative 42 times radical 3. So this process, multiplying the coefficients, multiplying the radicands, and then taking that next step to simplify the radicals expression is what you can do to multiply and then have your radical expression in simplified form. So we can add or subtract radical expressions when the index and the radicand are the same. So this first example could not be simplified, but the next two examples could. We keep the radicand the exact same when adding or subtracting because we're just collecting those like terms and we're combining the coefficients, either adding or subtracting. When multiplying radical expressions, we must have the index the same, but we don't have to have the same radicand. So you can multiply the radicands and they stay under the radical sign. But just make sure you go ahead and simplify into simplified radical form if there is a perfect square factor in the radicand. And we will divide next in our next video. But for now, simplifying radical expressions, there you go.